Okay, so on this page we're talking about atoms, so I always like to start with the subject of what it is, and I denote that with a triangle, because that just tells me, okay, that's my big overall subject. Start with atoms. And then I like to label the subheadings, so this one's characteristics of atoms, so I put usually a big circle. Characteristics of atoms. I'm just going to read through the text. Okay, so atoms are particles that are the building blocks of all substances. Even though they're about 1 billion times smaller than basketballs, atoms consist of even smaller subatomic particles called protons, which carry a negative charge, neutrons, which carry no charge, and electrons, which carry a negative charge. Okay, well, before I get to the charge, atoms are definitely something I want to note. So, atoms, building blocks of all substances. And then more importantly, what it's made of. So protons, neutrons, and electrons. And then I'm just going to quickly define each of those, because they're very important. So protons, and that little parenthesis thing means I might see them just labeled like that later on. So these carry a positive charge. And it talks about charge on there, so I'll get to that in a minute. And then neutrons, no charge, and electrons, electrons, and that has another little symbol there. And I try to put a little colon denoting the definition, okay, which carry negative charge. Okay, so charge, generally because it's bolded, that means it's important, so I'm going to mark out each of those pieces. So charge is an electrical property that attracts or repels other subatomic particles. So it's going to attract or repel the protons or the electrons, because those are the different subatomic particles, so that would be good. So subatomic, there's all three of these, because they're smaller than the actual atom. And protons and neutrons cluster in an atom's central core or nucleus. So charge, electrical property that attracts or repels subatomic particles. And these are my subatomic particles, so I know that. Alright, and then we get into the nucleus. So, nucleus. And so this is the center of an atom, made of protons, neutrons. And then they also say that electrons move around the nucleus. And then they got a nice figure here, so it's showing how the protons and neutrons are in the middle, and then electrons are going around it. So I'm going to say see figure 2.2, page 22. And that's like a good example for me. Okay, so let's keep going. So atoms differ in the number of subatomic particles. The number of protons, which is the atomic number, determines what the element is. Elements are pure substances, each consisting only of atoms with the same number of protons. For example, a chunk of carbon contains only carbon atoms, all of which have 6 protons in their nucleus. The atomic number of carbon is 6. All atoms with 6 protons in the nucleus are carbon atoms, no matter how many electrons or neutrons they have. Each element has a symbol that is an abbreviation of its Latin name. Carbon symbol is from carbo, the Latin word for coal, which is mostly carbon. Okay, so the big things to pull out of here are definitely atomic number and elements. So elements, I'm going to go with first, are pure forms of substances consisting of atoms with the same number of protons. Yep. Atoms with same number of protons. This number is the atomic number. The atomic number. Okay, so I got both of those put into just one quick line. And differences in neutrons. Neutrons and electrons doesn't matter. Or it doesn't change an element. Doesn't change what element it is. So then I start protons, and I would bring a line down here to elements because they're related. Okay, so all elements occur in different forms called isotopes. Okay, so here's something more important. So, isotopes. Same number of protons. Different number of neutrons. So that's where neutrons is much more important. So I bring a line down here to isotopes because these two are related. Okay, we refer to isotopes by mass number, which is the total number of protons and neutrons in the nucleus, the mass. So that's saying that these each have a mass of 1. Mass of 1 and mass number. And mass of 1 and mass number. And the mass number of an isotope is shown as subscript to the left of an element symbol. For instance, the most common isotope of carbon is carbon-12. So, a good example: carbon-12 versus carbon-13. And so isotopes, same number of protons, different number of neutrons, and refer to mass number. Refer to mass number for isotope.